Today, John and I will demonstrate how to rapidly prototype your design using high-speed analog devices converters and Xilinx high-performance FPGAs.
You can see here we have the Xilinx Kintex 7 KC705 FPGA development system. It includes all the basic components of hardware, design tools, IP, and pre-verified reference designs, including a targeted design enabling high-performance serial connectivity and advanced memory interfacing. The included pre-verified reference designs and industry-standard FPGA mezzanine connectors, FMC, allow scaling and customization with daughter cards such as the Analog Devices AD9250 FMC board, which we are going to show today.
For high-speed ADCs, the JESD204B interface is a high-speed successor to LVDS and CMOS interfaces. This native FMC card contains two AD9250 converters, complete clock solutions using the AD9517, and power, and it's easy to get set up and running on the Xilinx FPGA development system John just described. These high-speed data converters generate 4 channels of 250 megasamples per second at 14 bits per sample, a whopping 14 gigabits per second of data. By providing 5 gigabits per second bit rates per serial lane to support the converter to FPGA interconnect, it takes the minimum number of lanes to transfer that data, as well as providing additional valuable functions such as deterministic latency and harmonic clocking, allowing the 2 different converters to be synchronized. That's the hardware. Next, you can go to Analog Devices wiki page to download the software to make this all work.
And on Xilinx.com, you can search for JESD204. On the IP page you find, there is a link to evaluate our IP. This gets you access to our JESD204 lounge with all the docs so you can learn more. One tip on the digital side of things is that if you need deterministic latency between the converter device and the FPGA, or if you're using multiple converter devices and need coherency, then you will want a clock generator chip tailored for JESD204B. In addition to generating the necessary high-speed clocks for the converter and FPGA, such chips also make a sysref signal that gets routed to both the converter and FPGA. This signal keeps everybody's clocks synchronized. It works just like in the old movies. Gentlemen, synchronize your watches.
And an analog tip to keep in mind when prototyping converters at this sample rate using 204B is to ensure your clocks are as stable and jitter-free as possible. Sampling an IF signal of 70 MHz while maintaining an SNR of 75 dB will require a clock jitter of 400 femtoseconds or less. 204B does not remove this fundamental part of sampling systems. Thanks for watching. For more information, check out analog.com/JESD204.